Okay, we're finishing up chapter 16. We're in part 4. We've talked about relative time. We've talked about absolute time. So now we're going to look at the geologic time scale. It is a scale in which the 4.6 billion year history of the Earth is divided into time units of varying duration. It evolved back in the 19th century. We've incorporated both relative dating methods as well as dating sedimentary rocks. Now, if you remember, sedimentary rocks can rarely be dated radioactively, so we rely on interbedded volcanic rocks, ash falls, lava flows, igneous intrusions to supply us that minimum age. So if you look at the figure on the right side, we can see that the numerical ages for the sedimentary rocks are determined by dating the associated igneous rocks. So we can assume an age for our sedimentary rocks because they're bracketed by igneous rocks that we know an age for. Now, stratigraphy is the study of the composition, origin, areal distribution, and age relationships of layered rock. So our modern stratigraphic terminology includes two different units. Our first unit is what we call our lithostratigraphic units. These are defined by the physical attributes of the rocks, rock type. They give no consideration of time of origin. The basic lithostratigraphic unit is the formation. A formation is a mappable body of rock with a distinctive upper and lower boundary. Formations are divided into smaller units known as members, members into beds. They can be parts of a larger unit known as groups and also as supergroups. So in this picture, we're looking at the lithostratigraphic units in Texas. We have the Truxillo sandstone on the top. We have the Tecovas formation in the middle and our Quartermaster formation on the bottom. Now, our second type of unit is our biostratigraphic unit, and that is a body of strata recognized only on the basis of its fossil content. The fundamental biostratigraphic unit is the biozone. So you can see in this picture, we are only looking at what the fossil content is. Okay, you can see on the right, we have identified the different fossils present in the different zones. Now, the category of unit expressing or related to geologic time, we have our time stratigraphic units, also known as our chronostratigraphic units. Those are going to be our rocks deposited during a particular interval of geologic time. So we have our system is the basic time stratigraphic unit, and it's based upon a stratotype, which consists of rocks in an area where the system was first described. And then we have our time units. So our time units are our eon, our era, our period, our epoch, and our age. And they're used to refer to that specific geologic interval of time. The basic unit is the period. The period consists of shorter designations, such as the epoch and the age. Two or more periods can be designated as an era, and two or more eras can constitute an eon. Now, Our new dating techniques, they give us greater precision, and so they give the geologists a more accurate date for when and how long ago past climate changes occurred. So they help us correlate these changes with regional and global geologic events, so we can see if there's any connections. So we can reconstruct what climate was like in the past. So we look at the fossils of plants and animals, and they can tell us something about the environment and climate at the time of when these organisms were present. We can look at climate-sensitive sedimentary rocks to help us interpret past climatic conditions. Coal is formed in freshwater swamps where climatic conditions promote abundant plant growth. Evaporates, rock salts. They result when evaporation exceeds precipitation. Desert regions. Tillites are glacial sediments, so they're going to result from glacial activities. So we can use all this data now to help us reconstruct and help us learn about the past. This picture shows some of the sources of our climatic data. Our instrument records, our historical, our tree rings, pollen, oxygen isotopes, glacial evidence, plankton, and isotopes in our ocean sediments, rocks and fossils. All of these can be used to help us determine sources of our climatic data. Okay, this ends chapter 16.